We made checkers and I thought, well, as long as we are already in this hell, why not extend it? You know chess, right? I think every programmer, at least once in their life, has wanted to create chess. Now it's time for me to fulfill my destiny as a programmer. A long time ago, I was actually developing chess in Unreal. It was okay. The rules were working and the game was smart enough to show which actions were valid. I even made the pieces break when they captured. But I wasn't sure if Unreal was the right tool for this type of game. I mean, it can be, if you're willing to spend the time optimizing it. But at that moment, it felt like cutting butter with chainsaw. So I decided to make it in a game engine that's lighter on older devices and keeps the package size smaller. So after a long consultation session with my psychologist, I picked Unity. First, I chose a 3D model that I liked. To do my future self a favor, it's better to set the board origin to the square in the corner. This makes life easier when we want to move pieces. Additionally, the origin of each piece should be placed at the bottom. So when we move them, they stay on top of the board without any extra math involved. Now we need a simple UI for each team, so players know whose turn it is and whether the king is in check. Since Affinity is free now, we can easily manipulate some vectors to create something usable. Then we can place them in Unity's UI and in the future display them to the player at every step. And don't worry, we're following a specific art style, which is there is no art style. Now let's place the board at the board origin and move the pieces on top of it. Nice. We still have a gray plane underneath, which is kinda boring. This time I want to make it wooden, so I sampled the simple wood texture for it. And to draw attention to the center, I multiplied it by a circular gradient. Since we changed the board's origin, we can now move the pieces to the positive integer values. This also allows us to create a matrix that holds the state of the board. Luckily, we already have that from before, though it needs some tweaking. The first thing we need to do is to initialize the board state. To do that, we assign a number to each piece and make the black pieces negative, and use 0 for empty squares. After that, we let the first player try to move a white piece. But how do we move pieces? As you may remember, we created a large array of 2D vectors, each representing a valid move. I don't want to bore you by listing all of them and making the video unnecessarily long. I assume you already know them. But as an example, the knight moves in an L shape, which we can encode as one step in X and 2 steps in Z. Thanks to the script we have, we can simply select and move pieces using a raycast. It also considers the selected piece's valid move and checks whether the target position is valid. Now, we need to figure out how to define check. After we move our piece, we calculate its new move range. If that range includes the opponent king, the other player is in check. Then, we simply update the game state and switch turns. But wait a minute, we overlooked something. What if when we move our piece, we put ourselves in check? What should we do then? We can update the game state without actually moving the piece visually to see if our king ends up in check. To do this, we check every opponent piece to see if its attack range includes our king. If it does, we revert the state. Otherwise, we finalize the move. Alright, let's test this out. Let's move our knight, for instance. Wait, what? Oh, I put myself in check. It should be checking the other king. Attacking is just like moving, except that we delete the other piece. However, we consider a functionality to restore the previous state if the move turns out to be invalid. And to make it a bit amusing, I added a simple burst prefix. Now checkmate, our final boss fight. When a king is in check, and we cannot move any piece to escape, it is checkmate. Well, the first thing that came to my mind was to loop over everything, which requires several nested loops over all the pieces and all the movements. And let's hope Moore's law finally gets us. Let's see if we can find a better strategy. Remember how we update the state without actually moving the piece? We had a selected position before. Now there is none. So we need to generate the movement, update the state, and then verify check. I call this functionality pseudo move. Alright, so when the king is in check, we can simply identify the attacking piece and find the path from the king to it. Then we check if any of our pieces can capture that opponent or move into the squares in between. This way, we don't need to simulate every possible scenario. Now, we ask the final question. Can our king escape the check via pseudo-moving or attacking? If it can't, it is checkmate and the game ends. Alright, I think we've done enough, and I'm ready to scream into my pillow. So, I hope you liked this video. Thanks a lot for watching, and I see you in the next one.